Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject short range wireless communication. We're going to see direct conversion receiver. In previous video we have seen super heterodyne receiver, and today we're going to see the working principle of direct conversion receiver. So direct conversion receiver is also a high sensitivity receiver, whereas super heterodyne receiver is a very good receiver which is predominantly used in RF receiver. Super heterodyne receiver is also have high selectivity and sensitivity, whereas here the direct conversion receiver also have high sensitivity receiver. And the greatest advantage of direct conversion receiver is it does not suffer from image frequency problem, which is a significant problem in super heterodyne receiver. And we have to do a lot of steps, a lot of filtering methods to overcome that image frequencies in super heterodyne receiver, whereas we don't have the image frequency problem in direct conversion receiver. But even here we have issues with local oscillator, because local oscillator frequency will be same as that of the received signal frequency. So we will see the working of direct conversion receiver in this particular video. And as I said, direct conversion receiver is very similar to super heterodyne receiver, but we don't have any image frequency problem, and we can call this as zero IF receiver because the image frequency is zero. And the potential problem of image frequency in super heterodyne receiver is because it coincides with the desired signal, but that does not happen in direct conversion receiver. And as I said, it is a high sensitivity receiver, but uh, one greatest disadvantage here is we use a local oscillator signal, which is very similar frequency of the received signal, which can cause the potential interference, and that has to be overcome, right? And we have to design very securely in such a way that the design and layout are very important to limit the radiations of local oscillator signal so that it prevents the leakage back to the mixer and the RF amplifier, right? And predominantly we use crystal control local oscillator frequency because it is very accurate and stable. Coming to the working of direct conversion receiver, right? This is the very simple operation of direct conversion receiver, where here we will just normally we'll use the antenna to receive the signal, the RF signal, which is transmitter, and that particular signal is given to two different mixers, right? And these two different mixers we call this in phase and quadrature here, right? That because we use a local oscillator signal, that local oscillator signal is applied to both these mixers, but this local oscillator signal is applied directly to this mixer, whereas here it is changed by 90-degree phase shift and it is given to this mixture. So these two signals will have a 90-degree phase shift, right? So the signal here and here will have a phase shift between them, right? And these signals, after mixing with the mixer, it is sent to the low pass filter, where low pass filter will remove all the unwanted frequencies and it will select only the appropriate frequency, and that frequency will be further limited by using limiter amplifier, and it is boosted and it is given to the phase detector. Similarly here the signal is low pass filter limit and is sent to limiter amplifier, and then it is given to phase detector. Now the phase detector will receive both these signals, which will be out of phase with each other, right? And depending upon the phase difference between different components, this phase detector will send out the desired signal. That desired signal can be called as mark signal or phase signal, right? Depending upon the variation between the phase difference between the receiver signal, it will send out either the mark signal or phase signal, right? That is the original signal that is transmitted, right? So what is mark and phase? I like to explain this particular signal using a mathematical expression, right? The complete working of this receiver. But you have to understand here, all we are doing here is we are receiving the signal and we are amplifying it, and then we are multiplying with the local oscillator signal. Whereas while multiplying, we use direct local oscillator signal and the phase shifted local oscillator signal, so that it produces a phase shifted signal. And from this phase shifted signal, which is band limited and amplified, we obtain mark or phase signal, right? Now, whatever I said, that is the given here. The output of RF amplifier is supplied to two mixers, right? And the one mixer will have the local oscillator signal, the other will have 90-degree phase shift, and the output of the mixer is sent to the low pass filter, and then it is sent to a limiter circuit, limiter amplifier, and then phase detector. And depending upon the components which is received, right, it will send either the mark signal or space signal, that is binary mark or space, according to whether the input signal is higher or lower than the local oscillator signal, right? So depending upon this particular condition, right, whether the input signal is higher or lower than the local oscillator signal, it will send either binary mark or space, right? Now coming to this expression, so that you can understand how the receiver works, let us consider two signals. That is, one signal is at the top, another signal at the bottom, right? So the mark signal can be represented like this: cos 2 pi into f plus d into t. And the space signal can be represented by cos 2 pi f minus d, that is 90-degree out of phase, right? And two local oscillator signals can be represented as cos 2 pi and sin 2 pi, right? And let us say first we'll take only the mark signal. If you take mark signal, right, that mark signal is taken and it will be multiplied with this local oscillator signal, right? Local oscillator signal. And similarly, after multiplying, we'll obtain this particular component, and the same signal will be multiplied with the other local oscillator signal, right, which is phase shifted, that is sin 2 pi, and we'll obtain this particular component, right? So for the mark signal itself, that is for the mark signal itself, we will obtain two components, that is in phase component and as well as quadrature component. Similarly, if the input signal is space signal, right, then for that space signal also we will have in phase and as well as quadrature component. That is, you can see for the space signal, right, it is multiplied with the local oscillator signal, so that we will obtain all this combination of in phase and as well as quadrature component, right? And after this, it will be low pass filter, and then it is amplified. It is limited. It is amplified by the limiter amplifier, right? So the limiter amplifier, what it will do is it will square, and then that component will be removed by the local oscillator signal, right? So depending upon the components which is received, the double frequency components, that is IM, QM, IES, and QS, right, all are removed from the particular local oscillator, that is low pass filter, right? So and then from the low pass filter, it has been amplified, right? And whereas that amplified signal is sent to the phase detector, correct? Right? So now you can see here, these are the components after band limiting, after sending it to the low pass filter, right? So from this four signal, from this components, the phase detector will select the mark or phase signal depending upon the phase difference in each pair of this in phase and as well as quadrature component, and that will be the output signal which is received, right? So this is the working of direct conversion receiver, right? So this is the mathematical expression, but as I said, the working is very simple. The signal will be received, amplified, and then multiplied with local oscillator signal with directly and also with phase shift, and then it will be band limited and then amplified and sent to the phase detector, right? So today what we have seen is we have seen the working of direct conversion receiver. I believe this video will be very useful for you. Thank you, my dear students.